So hi everyone, I'm Omer. I'm a PhD student here at the Data Science and Decisions faculty. And I'm not a philosopher. I have... Okay. Okay, maybe I shouldn't... So yeah, I'm not a philosopher. I think that I have very little knowledge on philosophy, unfortunately. And actually, that's the main reason why I wanted to present this talk in this conference. So basically, this talk consists of lots of thoughts and observations and, you know, very high-level ideas on things that are currently missing in artificial intelligence. More specifically, some capabilities and qualities that we might want artificial intelligence to possess, but we think that they do not. And we try to organize them into a very high-level research agenda, and I'm very willing to get some feedback, you know, outside of the AI community on this one. So with that being said, let me begin by, you know, the standard opening about AI is great. It's doing really amazing things. So thinking about how we begin from being very excited about being able to classify objects, like using a discriminative model to classify whether this is a cat or a dog in the image. Then we moved on to the generative AI era, where we were able not only to classify, but also to generate image of cats and dogs. And now we're into the next level of agentic AI, where we design, develop, and deploy agents that arguably can act autonomously in an environment, learn, improve, communicate with each other, and so on. And there's this holy grail of achieving AGI, artificial general intelligence. I don't know what it means. Different perspectives try to draw a different image or different definition of what AGI means. I don't think that I'm the only one who feels confused about this term. And therefore, I think that, and not only me, many researchers believe that maybe a more practical path to pursue is to define some intermediate milestones that define sets of capabilities and qualities that we want AI to achieve, but they're not as general as artificial general intelligence, but they do have some more coherent definitions that we can actually test, measure, discuss, and hopefully improve. And today I'm trying to propose one such area of qualities that we want AI to achieve. So in order to present this, let me very briefly and on a very high level discuss the three core stages of the development of modern AI models or systems. So usually, and again, this is on a very high level and not necessarily accurate, but basically we have pre-training. If I'm thinking about a language model, then in this stage I'm feeding the model with lots and lots of unstructured data, unlabeled data, in this case text. And the purpose here is to be able to learn the high-level patterns that we want the model to learn. For instance, the language itself, the rules and grammar of the language. in the post-training phase, we usually use label data to teach the model how to do more specific tasks. For instance, we want him to be a useful assistant, then we need to somehow provide some examples of what specific behavior we expect from a model that already knows text and English. The last stage, and here I talk about alignment from the core computer science AI perspective, which might be different than how a philosopher thinks of alignment, but still there are obviously some connections. So here we want to teach the model how to be aligned with values of the human user. So for instance, we want the model to be able to identify some queries that it should not serve. For instance, if I'm talking about building a bomb, we want to teach the model to ignore or refuse to provide an answer. And the whole point of where we're going is that we believe that this notion of alignment is too narrow to actually achieve capabilities that we want AI to demonstrate in multi-agent, multi-stakeholder environments. So let me give some examples. So what could go wrong with only restricting to these three stages? So maybe we have an AI who is aligned with human values. So it knows that when a human interacts with it, it has the capability not to serve harmful tasks. But we have a very little understanding of how AI agents can potentially communicate and interact with each other. Maybe another AI agent can easily persuade my AI agent to provide this recipe for a bomb. Another thing that could go wrong is that agents act on behalf of other stakeholders, and these stakeholders have their own incentives. So we kind of have potentially self-interested stakeholders who delegate very important decisions to AI agents who then interact with each other. So first of all, as a game theorist, we know that these kind of interactions usually lead to inefficiencies and suboptimal outcomes in terms of social welfare. But it's even more than that. So we have not only the AI agents who make decisions, but also the stakeholders that design, deploy, train them. They also make some very important decisions. So this is another thing that we kind of ignore when we talk about alignment, at least in the narrow context of training and post-training models. So I already talked about stakeholders. So we want to organize these thoughts into one coherent framework of a broader notion of alignment. We term this artificial social intelligence. And the main observation is that aligning an AI agent with human values is just one very important, but just one narrow notion of alignment. And we need to think of alignment more of an ecosystem property rather than a property of a single AI agent. And we also believe that this is a necessary stage to design AI systems and ecosystems that lead to socially beneficial outcomes. So in the remainder of the talk, I will try to cover as many examples as possible, not to this. So I will try to cover examples for failure modes of artificial social intelligence, namely to scenarios that we observe in recent work that these broader notions of alignment fail. And to us, this raises questions of what should we do with it and how should we improve it. And okay, so I'll get to it maybe at the end. So let me begin with an example from the search ecosystem. When I talk about the search ecosystem, I talk about search engines where we have systems that serve user queries. A user can type a search query, and the system returns a ranked list of documents. And these documents are also written by publishers. These publishers could be humans, or nowadays they are usually AI agents, at least somewhere in the loop. So we have three kinds of entities in the search ecosystems. We have the user who writes a query. We have the document written by a publisher, and we have the system, the search engine itself. And while traditionally in the information retrieval literature, the main focus was on improving the retrieval system, the search engine itself, in order to lead to a great quality of retrieved documents. Now we have a multi-agent interaction, and the first observation, I'm not going to get into details, this is just an example from their paper, but a main observation is that when we have a multi-agent system where different kind of technologies are used to write documents, write user queries, and rank documents, the quality of the results depends not only on the ranker, but on the alignment between these three types of agents. Okay, so for instance, if I'm using a very naive keyword stuffing technique to promote relevant content, but the ranker uses a semantic language model that is very limited in how it is affected by keyword stuffing, then there is a misalignment between the language that the publisher talks and the retriever talks. So, so not necessarily a surprising observation, but I think that framing this observation as a new form of alignment is not the typical way, at least in the AI or information retrieval literature, it's not the typical way of how we think of alignment. Okay, this is not alignment between AI and human, it is alignment of technologies. Okay, so a different example from a different paper talks about delegation. Okay, so as I said before, we already see, and it's only expected to increase in volume, we already see economic decisions being delegated to AI agents to act on behalf of stakeholders. And the classical example is negotiation. So let's say I'm interested in buying the product, and there's a seller who wants to sell the product, and we need to negotiate the price. So maybe one day in the future, instead of us interacting, it will be my agent interacting with the seller's agent. And in this scenario, both of us need to make lots of decisions around how we design the agent that act on behalf of us. So it could be choosing the underlying language model, whether I'm using Claude, Gemini, etc. What prompt do I give? What instructions do I give to the agent? Whether I allow tool calling, etc. And yeah, so here the observation is that, okay, so this is just an evaluation of the performance of different language models against different language models. So in rows is the language models of the seller, and columns are language models of the buyer. And as a game theorist, when I see these kind of biometrics, this like always resembles a game, like a prisoner's dilemma. They usually, which is usually presented, a two-player game is usually presented as a bi-matrix. So yeah, there's a game, but notice that this is not the game that the agents are playing. Okay, here the players are not the agents. These are the stakeholders. The agents are the strategies in this game. This is the choices of rows and columns. Now, the entry of each such choice of the stakeholders is the result of the interaction of the game that follows. So this is not really a game, this is a metagame. This is a metagame played by the stakeholders, and the choices in this metagame affect the downstream application in which the agent themselves interact. So the second observation is that in this so-called AI ecosystem or agentic AI ecosystems, the agents are not really the only players, okay? So if we want a real notion of alignment, it should involve alignment between the agents themselves, as we've seen in the previous example, but also between the stakeholders themselves. So one way of thinking about this observation is that the classical human AI alignment can be seen as alignment between the stakeholder and the agent. The previous example was about aligning the agents themselves, and this example talks about aligning the incentives of the stakeholders with one another. So, yeah, so there are, okay, let me very briefly discuss another example. So this one is a simpler one. We don't really need to talk about agentic AI or anything like that. We can talk about a very simple classification model. Let's say that I have a model that needs to classify whether I should give a loan to a borrower or not. And obviously, such classifiers can do both types of mistakes, whether to not give, like not approve the request of someone who will return the loan, and approving the request of someone who's not going to pay back. And in the literature of fairness in machine learning, there are infinitely many notions of fairness. One of them is equal opportunity. I'm not going to dive into how it is defined. This is just some economic notion of fairness. And there are some methods of designing classifiers that satisfy this notion. Thank you. So, again, I'm not really going to get into details, but here there's a very nice observation that is demonstrated both in an economic, abstract theoretical model and like in real-world data, that even if each classifier itself in a, say, in a competitive market where we have multiple loaners, even if each classifier individually satisfies this equal opportunity fairness notion, then the outcome of the market level fairness can be arbitrarily bad. Okay, so here we can think of it as misalignment not of the technologies and not of the stakeholders, but of the objectives of the agents. So again, another failure mode of misaligned objectives in a multi-agent interaction. There are some more examples, which I can talk about offline. But let me just conclude by saying that, so this is just a list of papers that demonstrate some failure modes. Most of them are not even like the core contributions of the paper. This is just some byproducts that we identified along the way. And it made us think that, okay, so maybe we can resolve each one of these misalignments separately, but I think that the ideal outcome of such research agenda would be to design a unified framework where we can study all of these types of alignments within a unified framework, because this then allows us to, to make sure that we can control the trade-off between the levels of alignment and not just solve one problem and have no idea what we are doing about other problems. And I think that inherently this process requires like a multidisciplinary effort in defining what should we do and how can we actually do it. So any feedback is very warmly welcome, and thanks a lot for listening to me.
Thank you, Omer. We've got 9 minutes for questions. So let's begin.
So I see that you skipped it, but maybe you can talk a little bit about the examples about the traffic.
That's
how autonomous cars and human drivers share the road, because this is very interesting and something everybody's going to be.
I need water, sorry. Yeah, thank you, because I was really excited about this one. So there's an interesting observation. So nowadays, we have almost all vehicles being human-driven. We have our system of rules. It's arguably working fine. Thank you, yeah. But like, it's working somehow, on average, in expectation. And this is like one extreme of the state of this multi-agent environment. The other extreme is about like in 200 years or I don't know, where all vehicles are autonomous. This is also like probably a solvable case, because when all vehicles are autonomous, putting aside the terrifying possibility of cyber attacks, they should all be able to communicate, they respond optimally, they can sense, respond much better than human drivers, so this is also allegedly an easy case. The interesting case is what's going to happen in between, which probably is going to take a lot of time, where we have a mixture of human drivers and autonomous vehicles. So there's like a very nice simulator of urban mobility. It's called Sumo, and it enables experimentation with like lots of parameter tweaking and seeing how how some metrics change as we change this mixture of vehicles. But the question here is whether we can somehow intervene by designing better policies and rules to improve, for instance, traffics, etc. So here the observation is that one thing that we could and probably should do is to design separate rules for human and artificial drivers, because this enables us to exploit the extended capabilities of the autonomous vehicles to support the interests of the other types of agents, which in this case are the humans. For instance, there's this example of when there's an emergency vehicle arriving, the autonomous vehicles can sense it and then coordinate and make the path free to the emergency vehicle to pass. And this is something that human drivers probably are not able to do, never tried. So this is a nice observation, and we think that it shouldn't be applied to autonomous vehicles exclusively. I mean, in the internet, we have a mixture of human agents and artificial agents. Maybe we should enforce different rules, regulations. We probably have differences on norms emerging from these interactions. So this is like a very nice observation that maybe could be applied beyond autonomous driving.
Thank you very much.
Thank you. This was fascinating. I think it's really interesting how you're mapping the different misalignments at the individual level in order to make an argument for alignment at the system level. I do want to point out, I think, that when you reach that level, the system level or the societal level, you're going to have to contend with value conflicts as well. And so, for example, we don't have one agreed upon conception of fairness. So if you want to align the system to fairness, you're going to have to contend with different conceptions of fairness at the society level. So as humans, we live in a condition of reasonable disagreement about core value, right? And then one big value conflict, I guess, at the system level would be what is AGI for to begin with. So do you have any thoughts about how you approach the alignment challenge at that level?
Okay, so first of all, I 100% agree with this claim of, being able to study or even to solve these kind of problems. In some sense, this is the easier part of this puzzle, and it's not easy at all. But deciding, let's say that we're in a utopian world where we have this theoretical and algorithmic framework where we can control all of these trade-offs between notions of fairness and alignments and so on. I don't really think that there's anyone who really knows what we should do, or, maybe we have multiple perspectives on this type of, how should we resolve these types of trade-offs. Probably a huge open question that is inherently subjective. I don't think that there's going to pop out a solution that resolves these trade-offs. You just need to decide in certain contexts, for instance, in the loan approval market. There's this equal opportunity. There are 50 other notions of fairness. The regulator will decide on one notion. Probably will be a lot of disagreement in the population. I think that this is inherently the case. I don't think that we will ever be able to achieve better than this. I might be wrong, but this is at least how I view it. And again, I think that maybe I'm forcing this separation between how to solve the problems and what decisions we should make once we solve the problem. Maybe it's maybe I shouldn't think about these as separated challenges. So thanks for the comment. I'll be thinking about it.
Let's see if we've got 2 more minutes. If you've got another question, otherwise we'll go to lunch earlier, which is what we're gonna do.
Here there is no trade-off.